Picture the scene from a science fiction movie. Somewhere in a distant galaxy, an advanced alien civilization is monitoring space. They're sophisticated, technologically advanced. They have sensors that can detect signals from across the cosmos. And one day their instruments light up. A signal, a pattern, something artificial, coming from a small star system on the edge of a spiral galaxy. They tune in, identify the source. Earth, a living world, with intelligent life, with radio broadcasts, with cities and technology. They plot a course, set their course toward us, begin the journey to make contact. It makes for great science fiction. It makes for dramatic storytelling, but it bears almost no resemblance to how the universe actually works. Here's the reality. If an advanced alien civilization wanted to find Earth, they would face challenges so enormous that detection might be nearly impossible. Not because we're hidden, but because space is so astonishingly vast that finding one small rocky planet orbiting one ordinary star would be like trying to spot a specific grain of sand on every beach on Earth, without knowing where to look, without instruments perfectly calibrated for the search, without enormous amounts of time, and without a great deal of luck. I'm Keith Conrad, and this is Sidequests. Today, can aliens find us? Why the universe's vastness makes detection extraordinarily difficult, and what that teaches us about our place in the cosmos. Let's start with numbers. Big numbers, the kind of numbers that are hard to really comprehend. The Milky Way galaxy contains somewhere between 100 and 400 billion stars. Let's use 200 billion as a reasonable estimate. That's 200 billion stars in one galaxy, just the one we live in. Most of those stars likely have planets. Recent astronomical surveys suggest that nearly every star has at least one planetary system. So if there are 200 billion stars, there might be hundreds of billions of planets in the Milky Way alone. Earth is one of those planets, orbiting one ordinary average-sized star, the Sun, which is itself unremarkable. Not particularly large, not particularly small, just an ordinary star among 200 billion others. Now imagine you're an advanced alien civilization. You want to search the galaxy for signs of life. You point your telescopes outward. Where do you even begin? You could pick any star, 200 billion choices, and for each star you pick, there might be multiple planets, multiple targets. The problem is immediately overwhelming. Even if you could examine one star system per day, it would take you hundreds of millions of years to examine every star system in the galaxy. And even when you're looking at a particular star system, Earth would be almost invisible. Let's say aliens decide to point their telescopes directly at our solar system. They're looking for planets around the Sun. What do they see? The Sun. Brilliant. Overwhelming. Essentially a giant light source that drowns out almost everything else. And somewhere near that light source, there's Earth. Tiny, rocky, reflecting maybe 30% of the light that hits it. The comparison is roughly equivalent to trying to spot a firefly circling around a stadium spotlight, or a dust mote floating next to a lighthouse beam. The main light source, the Sun, is so much brighter than the reflected light from Earth that detection becomes extraordinarily difficult. Modern human astronomers have managed to discover thousands of exoplanets, planets around other stars. That's an incredible achievement. But how did we do it? Mostly not by looking directly at its planets. Instead, we use indirect methods. The transit method is the most successful. When a planet passes in front of its star, from our perspective, the planet blocks a tiny bit of the star's light. We can detect that small dimming, use it to infer that the planet is there. The method works. It's how we've discovered most of the thousands of exoplanets we know about. But here's the limitation. You can only detect a transit if you're positioned in just the right location, if you're looking at the star at the right angle, if the planet's orbital plane is aligned with your line of sight. Imagine Earth orbiting the Sun. From most angles in the galaxy, Earth never passes in front of the Sun at all. From most vantage points, we would be invisible. Only observers in a narrow slice of the galaxy along Earth's orbital plane would ever see Earth as a transit across the sun. Most alien civilizations wouldn't even be positioned to see us. They could be looking directly at our star and never detect us. But let's say they get lucky. Let's say they're positioned exactly right. They see Earth transit the sun. Now, they might be able to do something more sophisticated. They might be able to analyze Earth's atmosphere. When light from the sun passes through Earth's atmosphere, some of that light is absorbed by the molecules in our air. Different molecules absorb different wavelengths. Oxygen, water vapor, methane. These gases leave signatures in the light. Spectroscopic signatures that advanced telescopes can detect. If an alien civilization had incredibly powerful telescopes, far more powerful than what we currently possess, they might be able to detect these gases in Earth's atmosphere, and they might realize something important. This planet has oxygen and water. Signatures of biological activity, so they would know there's life on this planet. Probably microbial life at minimum, possibly more complex life. That's significant. That's a discovery. But here's what they would not know. That there are intelligent beings on this planet. That we have built cities, that we've developed technology. That we're broadcasting radio signals into space. They would detect life. They would not detect humanity. Now let's talk about radio signals. Because humanity has been broadcasting for about 100 years. Radio, television, radar, military communications, satellites, all of it leaking into space, and inadvertent broadcasts of electromagnetic radiation. You might think 100 years of broadcasts, that's a lot of signal. Surely someone could detect that. But space is vast, and electromagnetic radiation weakens dramatically with distance. Our earliest radio broadcasts from around 1920 have traveled about 100 light years into space. That's a sphere of space roughly 200 light years in diameter, centered on Earth. That sounds impressive. A sphere with a diameter of 200 light years. Huge, right? Except the Milky Way is about 100,000 light years across. Our radio bubble has reached only a tiny fraction of it, maybe 0.2% of the galaxy's diameter. And that's just in terms of distance traveled. The signal strength is another problem. As radio signals travel through space, they spread out, they weaken. By the time they've traveled dozens of light years, they're almost indistinguishable from background radiation, from cosmic noise. TV broadcasts become especially faint at distance. An alien civilization 30 light years away would struggle to detect our television broadcasts. They would need enormous receiving arrays, long observation times, and they would need to know where to look. Radar systems are brighter, they emit more power, but they're directional and intermittent. They don't broadcast continuously in all directions. To detect Earth's radio signals, an alien civilization would need exceptionally advanced technology, enormous receiving arrays, long observation periods, to know somehow where to direct their receivers. Most civilizations, even advanced ones, probably wouldn't be able to detect us. The signal would be lost in the noise, but there's another problem that science fiction rarely addresses. Time. Because of the speed of light, distant observers don't see Earth now. They see Earth's past. Think about this carefully. Light takes time to travel, so when someone looks at us from a distance, they're seeing a delayed image. From 65 light years away, observers would be seeing Earth as it was 65 years ago. The dinosaurs would be disappearing. The last asteroid impact would be recent history. From 500 light years away, there would be no humans, no agriculture, no civilization. Just a planet with some kind of biological life, but nothing resembling human civilization. From 2,000 light years away, the Roman Empire wouldn't have happened yet. No cities, no technology, no radio broadcasts. From 10,000 light years away, modern humans wouldn't have developed agriculture yet. We'd still be hunter-gatherers. What this means, every observer in the galaxy sees a different version of Earth's history. Nobody sees us right now. We're always in someone's past. An alien civilization that detected Earth today, right now in 2026, would have to account for the fact that their light travel time to Earth means they're seeing years or decades or centuries of Earth's past, depending on their distance. If they're trying to make sense of what they're detecting, they're trying to piece together a civilization's development from ancient light. Let's say somehow an advanced alien civilization manages to find our solar system, detect that Earth has an oxygen atmosphere, intercept some of our radio broadcasts, and realize they're artificial. They decide to send us a message. Now they face another problem: distance and time. If they're 100 light years away, their message takes 100 years to reach us. By the time it arrives, a century has passed. Humanity has changed. Technology has evolved. The civilization that received the message might not even exist anymore in its current form. We send a reply. That takes another 100 years. By the time our reply reaches them, 2 centuries have passed. They might have gone extinct in the meantime, or evolved into something unrecognizable. Every communication across interstellar distance becomes a multi-generational project. A conversation where each speaker is separated by decades or centuries from hearing a response. It's not impossible, but it's profoundly, deeply difficult. This raises an interesting question. Should we be trying to be found? There's an ongoing debate in the scientific community. SETI, the search for extraterrestrial intelligence, is primarily passive. We listen for signals, we don't send them, but some scientists argue, why not actively transmit? Why not send deliberate messages into space and announce our existence, invite contact? Others argue, we don't know what's out there. We don't know the nature of civilizations that might receive our signals. Broadcasting our location to the universe might be dangerous. We might be advertising our presence to civilizations that would consider us a resource to exploit. The debate remains unresolved. There's no consensus. Some scientists support active SETI, others advocate for continued silence, but the practical point remains. We could broadcast all we wanted and the vast majority of the galaxy would never hear us. The signal would be lost in the noise, indistinguishable from background radiation. So let's step back. Let's think about what all of this means. If intelligent aliens are searching the galaxy for signs of other life, they would face challenges almost incomprehensibly vast. Finding one planet among billions of possibilities, detecting the planet through direct observation or transits, reading the planet's atmosphere to identify biological signatures, intercepting radio signals that are traveling through space, weakening with every light year of distance, accounting for the fact that they're seeing the planet's past, not its present, figuring out somehow that intelligent life exists on the planet, not just simple life, but technological civilization. And that's assuming they even decide to look in our direction in the first place. The universe is so vast, so old, so filled with possibilities that finding any particular civilization might be extraordinarily difficult, even for advanced species. This actually addresses a version of the Fermi paradox. The paradox asks, if intelligent life is common, where is everybody? One possible answer, they're out there, but the universe is so big. The distances are so vast. The problem of finding any particular civilization is so difficult that even advanced civilizations might spend millions of years searching without finding each other, not because life is rare, but because the universe is vast. The real lesson here is humility. When we imagine aliens searching for us, we imagine them as all-knowing, able to detect us instantly, to locate us precisely, to find us without difficulty. The reality is probably the opposite. If advanced civilizations are searching, they're probably struggling. They're probably looking in many directions, finding nothing, detecting only cosmic noise and random signals. Earth is not invisible. A sufficiently advanced civilization, positioned correctly with the right technology at the right time, might detect signs that our planet is alive. But detecting that humans exist, that we've built cities, that we're broadcasting radio, that would be vastly more difficult, and most civilizations probably wouldn't even be positioned to see us. Wouldn't have instruments calibrated for our particular star, wouldn't know where to look. The universe isn't hiding from us, but neither is it announcing us to everyone. We're just here. One small world around one ordinary star in a galaxy containing 200 billion stars. Remarkable to us, but probably unremarkable to the universe. When we ask, why haven't aliens visited Earth? We often imagine they know we're here, that they can see us, detect us, find us. But perhaps the more humbling possibility is that they don't. Not because we're unimportant, but because the universe is so astonishingly large, so vastly expansive, that even intelligent civilizations searching for each other might never find each other. Earth is not special in being hidden, but it's not special in being obvious either. We're here, we exist, we broadcast into space, we're real, but we're also tiny. Our signals cover only a fraction of the galaxy. Our planet orbits an ordinary star. From most vantage points, we're invisible. The universe is not ignoring us, but it's not focused on us either. It's just big. You just won't believe how vastly, hugely, mind-bogglingly big it is. And that vastness might be the real answer to Fermi's question. Why don't we see other civilizations? Not because they don't exist, but because finding each other, detecting each other across the cosmic distances, might be nearly impossible, even for beings far more advanced than ourselves. The universe is so big that civilizations could evolve and die. Cities could rise and fall. Entire worlds could come and go. And other civilizations would never know. The signals would be lost in the cosmic noise. The planets would remain invisible. The civilizations would remain unknown. That's not a tragedy. It's the cosmic reality. We're not alone in the universe. But we might be functionally isolated by distance and the physics of detection. And that's humbling in the best possible way.